Hey there, welcome to 10.3. So if you look at the income that we have here, the idea is on the income sheet, the idea is that we're looking at a certain number of units based on a certain price. And in the last module, we came up with different scenarios to figure out what would be the best mix between number of units produced and our revenues, also the price point in our two matrix. Then we went through the big one and we came up with our scenario summaries. Now, what we're going to do here is expand that idea of different possible combinations to producing a larger amount of items. So these are the models of the item, and basically, if you look at these models, it kind of is the same idea as here, right, our 335, but instead we have a whole range. Now, the reason for this is that we want to have a mix of expensive models and cheaper models. In the more expensive models, we make a higher profit, but there's much less demand. The cheaper models, there's a lot more demand, but lower profit. So we talked about under the status quo scenario, IRENA estimates the company can sell 12,000 mowers. Assuming the company sells 3,000 of each model, then we'd have $300,000. But we want to find the optimal product mix. So what we looked at before on the income was the overall numbers, but now we want to break it down even further. So let's continue the examples that we've been working on page 632. And we're going to go to the yellow box. So we're on the products mix worksheet. And let's go to B11. Okay, and we're going to put in 3,500. And then in C11, we're going to put in 3,500. In D11, we're going to put in 2,500. And then finally in E11, we're going to put in 2,500. Under this product mix, the total number of mowers is unchanged, remaining at 12,000 units overall, but the net income of the company, shown in C24, has changed dramatically. Let's take a look at that. So now we're at C24. It drops down to 258,000, a decrease of $42,000 from the product mix that's equal between the four models, right? So right now, if we look at our scenario, we've gone down by $42,000 from where we were before. Okay, you could see, we could take a look at a different product mix to see if we could change it up a little bit. In the range B11 to E11, so let's go to B11 to E11. Let's try a different mix. We'll put in 2,500, 2,500, 3,500, and 3,500. Okay, with this product mix, our net income increases by 42,000, and we're now at 342,000. So what we're really trying to do is figure out what is the best balance between these various components. Okay, so here's the thing. There might be other combinations that we could try that would be more profitable. So if we want to run through all the numbers to find what the best possible scenario should be, we could use Solver to do that. So if you haven't already done it, go back and turn on the Solver plugin, which is going to be under Data, and you should have an Analyze tab with Solver. If you don't have this, then go back and watch the Solver video for section 10.3. It should be in Moodle. Okay, and then we'll jump ahead to page 636, and we will work on getting Solver turned on and running some scenarios. Okay, so let's take a look. We're going to go to Analyze. We'll click on Solver, and we get this box that comes up. Okay, so we'll click on cell C24. We're making sure that max is selected. This option tells Solver to find the maximum value for C24. And then we'll click by changing variable cells. And then we're going to select the range. We're going to go B11 to E11. And those are the numbers that we've been changing up until now. Okay, We'll hit enter. And now we press solve. Okay, so we get this error. And you'll notice in the back, if you look at figure 1035, solver will find huge, gigantic, or unrealistic numbers. And that is not going to work. Okay, so what do we do instead? We will click on Restore Original Values. We'll click on the second option, Restore Original Values, and we'll press OK. Okay, so basically our original values didn't work, and we'll reset them in a second. Okay, so the reason why the numbers went crazy is basically because they kept on getting bigger and bigger until they just had no solution. So what we're going to do is we're going to add constraints, and that is going to make it stop at a particular number. Okay, so let's go back to Solver. Okay, and then under Subject to the Constraints, we're going to press where it says Add. Our cell reference is going to be C19. Okay, we'll put in equals, and then in the constraint box, we'll type in 12,000. So basically, we want to make sure that C19, our optimal scenario, stays at 12,000. We'll press OK. And then this appears here. Now let's try when we press solve. Okay, so now we have a very different mix. So it says we should only produce 12,000 of these mowers, and everything else should be 0. Okay, so that sounds great. That's going to bring us in a lot of money. It's going to bring in $732,000 or $432,000 more. The problem is that we can't limit our production to only one model because there's not enough demand for that model. Also, we want to diversify the offerings by producing and selling a variety of power lawnmowers to attract more customers. So we have to add more constraints that we have to produce at least 2,500 of each model. And then on top of that, we could see what else we're going to do. Now, it's also important that you see here we have a decimal place. Since we can't produce a fraction of one lawnmower, we have to make them in whole numbers. Okay, so it's going to have an integer value that's going to return 12,000. That will be the actual number of lawnmowers that we should produce. Okay, so we're going to click on where it says Restore Original Values, and we're going to go to Return to the Parameters to Solver. We'll press OK, and it brings back up Solver. So now we're going to hit Add again, and this time we're going to go B11 to E11. Okay, so we'll grab that cell reference, and we're going to say that it has to be at least greater than, and we're going to put in our 2,500. Okay, so that means for each of these items, it has to have at least 2,500 mowers. Now we're going to press Add again, and we're going to go, our cell reference, we're going to go B11 to E11, and we're going to click on integer as the constraint type. Okay, and we're going to hit OK. So now let's recap what we have. A number has to be an integer, meaning a whole number. Each one has to be at least 2,500 or equals to 2,500. And overall, our C19 has to equal at least 12,000. Okay, so now when we hit solve with those constraints, let's see what it came up with. So our new mix is we have at least 2,500 of each model, but for our high-end model, it says we should build 4,500. Okay, and we can see that reflected in 1039. So we see from this product mix that now we're making $72,000 more. We are bringing in $372,000, which is far better than we had before. Okay, but let's take a look at one more part. So if we go here on the side and we take a look at our scenario, here we have parts available, but now for front power axle and variable speed control, we're missing a whole bunch of parts. Actually, let's run solver again and recheck. Okay, so after running solver, now we have a whole bunch of parts missing. So that's not good. So we want to add these things as constraints to make sure that we are going to have enough parts to produce the motors, to produce the lawnmowers. Okay, so what we'll do is we're now in the box at the bottom of page 642. We reset everything back to 3000 and we'll go into solver. And then we're going to hit add. Okay, and then we're going to reference J28 to J46. And we want those to be greater than or equals to 0. And we're going to hit OK. Okay, so now we have that new line in here. And that means that for our parts, which are in J, when we run our solver scenario, we have to have at least one part, or 0 parts, for all these items, because now this column is actually called remaining, right? That's how many parts we have left over. Right now, this is what is available, used, and remaining based on 3,000 of each. Okay, so now we're going to hit solve again. And let's take a look at what it found. So basically, now we're saying our optimal product mix is 3006, 2680, 2603, and 3711. And let's take a look. Let's press OK. Let's take a look down here. Okay, we did actually run out of front power axles. We're now at 0, as well as this engine, as well as the cutting deck for 22 inches, right? So those things we got down to 0 with, but we found the exact product mix, which allowed us to use just those right parts, right? Price-wise, this is a $25,000 increase. That's now bringing in $325,000. So it's balancing those different factors between price and cost and available parts, right? And we can see that in figure 1042 on page 644. Okay, so before we continue, let's just take a quick note of the section called Exploring the Iterative Process on page 644 and 645. Basically, it says that Solver, what it's trying to do is find what is the best mix between all these different components. So between the number of mowers, between the parts, between the price, we're trying to find the absolute best, right? And to do that, it just basically runs the calculations by testing each scenario over and over again, trying to find the best one. When I find one that works, it just carries on with that and says, well, if it works for 2,000 mowers in this product mix, what about these different product parts? And then plays around with those. And that's called an iterative process, just repeating it over and over again to find the best option. Now that best option is called the global optimum, and the global optimum is the best possible overall combination. So it's the best in terms of money, quantity, parts, the whole deal. Like all our factors are factored in there. Whereas the local optimum is maybe we can't reach the best possible scenario right this second with the amount of information or constraints that we have in there. So instead, what we're going to try to do is find what's the nearest closest number that's going to be okay for now, and then we could try to refine the model, right? So you could read about that and some of the different methodologies and formulas to do it on the top of 645. Okay, and there's different methods that we could use to get to the global optimum if we're not quite there yet. Okay, so the next thing we're going to do is create an answer report, which is similar to a scenario summary that we had before. This is important because it says both how close we are and also what the factors were in there. So let's take a look. We're in the yellow box now on page 645. Okay, so I reset everything to 3000. I go back to solver and we're going to press solve. Okay, so then we're going to click on answer in the reports box, and then we're going to press where it says keep solver solution, and we're going to go to where it says outline reports. Okay, and then finally we're going to click on OK. And we now have a new sheet down here called Answer Report 1. And this is auto-generated for us, and this will tell us it's the report, when it was made, solver found the solution. It's going to tell us for the cell, which we could rename, net optimal income, the beginning and final value, what are our variable cells, and what are our constraints. Right, so by playing around with these, we could potentially find a better one. If you want to see more detail about how each of these things came about, we could open it here on the side. This is like what formula went in to create it. This is the sensitivity and how many steps it took to get to the solution. Here is our optimal number of units with our constraints here. This is the when we had the parts. So this will tell us the cell value, formula, status, slack, etc. And here's our optimal mix down at the bottom. So we're able to open that up and get this auto-generated report about what solver did and what the process was. Okay, so one of the last things we're going to do is show how to save the solver model. So we're going to go back to the product mix sheet, and we're going to go back into solver. Then we're going to press load and save right there. And it's going to say to load, select a range where we have a saved model. To save, select an empty range. Okay, and we need 8 cells to save it. So basically it's going to save the formula there. So in this case, it says pick A27 down to A34. There we go. Okay, and then we're going to hit save. And it's basically going to copy our saved formula into here, which we could do the exact same thing in reverse and load it from these cells to bring it back. Okay, but it's important that we remember what this is. So we're going to go to, we'll type in max net income model, and we'll format it up just because they asked us to. How about that? And then we'll even put this in a box. Okay, and then we'll remember when we want to reload it if we have different scenarios, or you could have a page just of your scenarios saved in different models, so we're able to load them back up. Okay, and the last step that you can see on page 649 is now that we have one of these, we have the ability to create a whole bunch by changing not just the optimal product mix, but we're able to change other things as well to see how we can impact that. So could we change the total material cost? Could we, for example, change sale price per unit or something else? So we could build a model looking at the best fit for those multiple factors. And that is the end of 10.3. Congratulations. Take a look at the homework and have a great one.